Magnitude of A dot B divided by magnitude of A into magnitude of B is equal to what? We know that it is a cos theta. 7 minus 3 is nothing but you are getting 4. 4 plus 56 is 60. So therefore the answer you are getting for A vector dot B vector is nothing but 60, right? This is your answer. If you want, you can further simplify. That is root 14 into root 6, which is 14 into 6. You can multiply that one. Otherwise, you can keep it as it is. Okay. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics Faculty at Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. In the last session, we have learnt many problems on cosine of an angle, isn't it? And in today's session, dear students, here we are having session number 5, which is a chapter number 10 in your NCERT called Vector Algebra. And here we are going to have some more problems related to the cosine of an angle. Then you have to know what you mean by the A vector dot B vector, how to do it. And if A vector dot B vector equal to 0, then they are said to be perpendicular to each other, isn't it? Now let us move on to the problems of what? Find the angle between the vectors. A vector is equals to I minus 2j plus 3k and B vector is equals to 3I minus 2j plus k. Now here they have asked you to find out the angle, means you can go for a cross product or a dot product. Since you have never know what you mean by the cross product, we'll know only the dot product. Here we are doing by a dot product method. After this, we'll be learning what you mean by the cross product also. Okay. Now here we'll be taking cos theta is given by A vector dot B vector divided by magnitude of A vector dot magnitude of B vector, right? Now let us find out what is first A dot B vector. So A vector dot B vector is given by what? You are going to multiply the coefficient of I. Here it is 1 and here it is 3. Similarly, coefficient of J is minus 2. There in B vector is also minus 2. Similarly, coefficient of K is 3 in A vector and coefficient of K is 1 in B vector. So A vector B vector is given by 1 into 3 plus minus 2 into minus 2 plus 3 into 1. So which implies that 1 into 3 is 3, minus into plus is minus 4 plus 3. Now you can have 3 plus 3 is nothing but 6. 6 minus 4 gives you 2. So A vector dot B vector, you are getting the value which is equals to 2. Let us do what is the magnitude of A vector. Magnitude of A vector is given by square root of coefficient of I, coefficient of J plus coefficient of K whole squared, right? So 1 squared plus minus 2 whole squared plus 3 squared. Be careful here 1 you are having minus 2 and 3. That's I am taking. So which will be implies that 1 squared is 1, minus 2 squared is 4, 4 plus 1 is 5, again 3 squared is 9, 9 plus 5 is root 14. Okay. Similarly, let us calculate magnitude of B vector, which is given by same like you have to take the coefficient of I, J, K, 3, minus 2 and 1. So 3 squared plus minus 2 whole squared plus 1 squared, which is 3 squared is 9, minus 2 whole squared is 4, 9 plus 4 is 13, 13 plus 1 squared is 14. So under the root 14. So cos theta you can substitute as A dot B vector, we got it as 2 divided by root 14 into root 14. Now root 14 into root 14 is 2 divided by 14. Otherwise you can have 2 1s are 2 7s are, which is equals to 1 by 7. If cos theta is equals to 1 by 7, so theta will be is equal to cos inverse of 1 by 7. That's it. So this is what the angle made by that vectors. Okay. I hope you got this solution. Now, we'll be moving on to the next problem. Find the angle between the vectors. Same like A vector I plus 3j plus 7k. B vector is 7i minus j minus plus 8k. But here they have changed the coefficient of ijk. That's it. Same procedure you are doing. First, write down the formula. Writing the formula is very important step. A vector dot B vector divided by magnitude of A vector into magnitude of B vector. Now you can find out what is A vector dot B vector by multiplying the coefficient of I, J and K in both the vectors. So here it is 1, in B it is 7. So 1 into 7 plus here it is 3 and there it is 1. So 3 into minus 1. Be careful, it is minus 1 plus 7 into 8. Coefficient of K. So which will be 7 minus 3 plus you are getting 56. Correct? So 7 minus 3 is nothing but you are getting 4. 4 plus 56 is 60. So therefore the answer you are getting for A vector dot B vector is nothing but 60, right? And then let us find out what is a magnitude of A vector. Magnitude of A vector is under the root of 1 squared plus 3 squared plus 7 squared, which will be getting the value 7 squared is 49, 3 squared is 9, 49 plus 9 is nothing but 58, 58 plus 1 is nothing but under the root 59. Correct? So therefore, you are getting, see, 7 squared is 49, 49 plus 3 squared is 9 you are getting. So 49 plus 9 is nothing but 58, 58 plus 1 is nothing but 59, correct? Now, what is magnitude of B vector? Magnitude of B vector is under the root of 7 squared plus minus 1 whole squared plus 8 squared. So which is given by the value 8 squared is nothing but 64. 64, 7 squared is nothing but 49. So you are going to get 60 plus 40 is 109 plus 4 is 113. 113 is, this is nothing but 114. So 114 is your answer for magnitude of B. Now substitute here, what you are going to get? 60 divided by root 59 into root 114. Correct? So cos theta you are going to get 60 divided by under the root 59 into root 114. If you want you can simplify, otherwise you can keep it as it is. This is cos theta, but theta will be is equal to what? Cos inverse. So cos inverse of 60 divided by root 59 into root 114. And this is your answer for this question, dears. I hope you understood all this step. Now we'll be moving on to the next type problem. What they've asked. If A vector is equals to 2i plus j plus 3k and B vector is equals to I minus j plus 2k, find the first one, the projection of A on B. What is the projection of A on B is given by? This is given by the formula A vector dot B vector divided by magnitude of B vector. If it is projection as A on B, then denominator magnitude of B vector you are going to get it. Now first solve A vector dot B vector. It is given by 2 into 1 coefficient of I here 1 plus 1 into minus 1, 1 into minus 1 plus next 3 into 2, 3 into 2. Now which will be 2, 1 into minus 1 is minus 1, 3 2s are 6. Now you are getting 2 minus 1 is 1, 6 plus 1 is 7. So A dot B vector is nothing but, that is A vector dot B vector is 7. Now you need to calculate what is magnitude of B vector. So magnitude of B vector is square root of 1 squared plus minus 1 squared plus 2 squared. So which will be getting the value under the root of 1 squared is 1, minus 1 squared is also 1, which will become 1 plus 1, 2. 2 squared is nothing but 4. 4 plus 2 is nothing but 6. Under the root 6 you can write it. Now calculate this by substituting. So which will be equal to A dot B vector is nothing but 7 divided by root 6. And this is your answer. You are going to get it, the projection of A on B vector. Okay. Now, we'll be moving on to the next problem. Same, here they have given if A vector is equals to 2i plus j plus 3k and B vector is I minus j plus 2k, then find the second option. They have given the projection of B on A. What is the projection of B on A is given by A vector dot B vector. Here B on A means magnitude of A vector. So, you know already how to find out A vector dot B vector. Once again, let me 2 into 1. 2 into 1, again 1 into minus 1 plus 1 into minus 1, again 3 into 2 plus 3 into 2. So which will be 2 minus 1 plus 6. So the answer you are going to get it as 7. Now we need to find out the magnitude of a vector. So which is square root under. So 2 squared plus 1 squared plus 3 squared. 2 squared plus 1 squared plus 3 squared. So the answer 2 squared is 4 plus 1 squared is 1, 5 plus 3 squared is 9. 5 plus 9 is nothing but 14. So under the root 14. So the answer you are going to get it as here 7 divided by root 14. Okay, this is your final answer. You are going to get it. I hope you understood this one. Now we'll be moving on to the next problem, dears. If a vector is equals to 2i plus j plus 3k and b vector is equals to I minus j plus 2k, find the cosine of an angle between a vector and b vector. Here they have mentioned the cosine of an angle. So therefore you need to find out cos theta given by the formula a vector, which is a dot product, divided by magnitude of a vector into magnitude of b vector. Now let us find out first a vector dot b vector. So which is given by 2 into 1. So 2 into 1 plus 1 into minus 1, 1 into minus 1, 3 into 2 plus 3 into 2. So which is 2 minus 1 plus 6, which is 7. So you need to find out now magnitude of a vector. As we know that magnitude of a vector is 2 squared plus 1 squared plus 3 squared, which is given by 4 plus 1, 5 plus 9 is root 14. Similarly, magnitude of b vector is given by under the root of 1 squared plus minus 1 whole squared plus 2 squared. So which is 1 plus 1, 2, 2 plus 4 is 6. So root 6. So let us substitute here. So which you are going to get cos theta will be equal to a dot b vector is 7. So 7 divided by magnitude of a vector is root 14. Magnitude of a vector is root 14. Magnitude of b vector is nothing but root 6. Okay. So this is your answer. If you want, you can further simplify. That is root 14 into root 6, which is 14 into 6. You can multiply that one. Otherwise, you can keep it as it is. Okay. So therefore, you are getting theta will be is equal to cos inverse of 7 divided by under the root 6 root 14. And this is your final answer. You are going to get it, dears. Okay. I hope you understood this one. So these are all the types of questions they can ask you by a cosine of an angle or projection of A on B or B on A. Now we'll be moving on to the next is nothing but the Cauchy-Schwarz inequality. This proof they are going to ask you in the examination. So for any two vectors, A vector and B vector, magnitude of A dot B vector is lesser than or equal to magnitude of A vector into magnitude of B vector. The proof goes like this. The inequality holds trivially when either A vector is equals to 0 or B vector equal to 0, not both at a time. So this is what you have to write. In the situation we have magnitude of A vector B vector equal to 0, which implies that magnitude of A vector dot magnitude of B vector. But let us assume that these two vectors are not equal to 0. Okay, magnitude of A vector not equal to 0, which is not equal to magnitude of B vector. Then we have magnitude of A dot B divided by magnitude of A into magnitude of B is equal to what? We know that it is a cos theta. So if this is a magnitude, obviously this also magnitude of that. You know, magnitude of cos theta never lie between, what is that, never go beyond 1. So therefore it is lesser than or equal to 1. The range of cos theta is between -1 and 1. So here we are taking lesser than or equal to 1. So therefore you can cross multiply this. If you cross multiply here, you are going to get 1 into magnitude of A vector into magnitude of B vector is magnitude of A dot magnitude of B, and this is your final steps you are going to get it. Okay, I hope you understood this step. Now we'll be moving on to the next inequality called as a triangle inequality. This is also important. For any two vectors A vector and B vector, we have magnitude of A vector plus B vector is lesser than or equal to magnitude of A vector plus magnitude of B vector. So here let me take it as the inequality holds trivially in case of A is equal to 0 or B will be is equal to 0. That is A vector equal to 0 or B vector, and then let us assume that both magnitude of a vector A and vector B is never equal to 0. So you know that magnitude of A plus B, correct? So magnitude means what? It will becoming a negative. So inside the magnitude, the negative value will become positive and positive also will become positive. Removing the magnitude sign and writing it as whole squared, it will not make any difference, isn't it? So you are going to take the magnitude and removing that magnitude and writing the whole square, it will not make any difference. So here I am writing A vector plus B vector whole squared. So this can be written as A vector plus B vector into A vector plus B vector. Now you can multiply each, which will be giving you A vector dot A vector, again A vector plus A vector dot A vector is over A vector dot B vector, similarly plus B vector dot A vector, writing as A vector dot B vector only, similarly B vector dot B vector, B vector dot B vector. So which will be giving you A vector dot A vector is nothing but magnitude of A vector, correct? So and then this will be magnitude of B vector whole squared plus 2 into this, I can write it as magnitude of A dot B. So this never be lesser than or equal to what? The magnitude of A vector dot plus B vector. So therefore I can write this one as which will be equal to lesser than or equal to, so magnitude of A vector plus B vector is lesser than or equal to, so this magnitude of A vector plus magnitude of B vector whole square plus 2AB can be written as A plus B whole squared, isn't it? Now here, this is according to A plus B whole squared, which is nothing but magnitude of A squared plus magnitude of B squared. So left hand side you are having magnitude of A plus B whole squared, which is nothing but magnitude of A squared plus magnitude of B squared. So which implies that you can have magnitude of A vector plus B vector can be lesser than magnitude of A plus magnitude of B. That's it. So this is what the proof will go to us. Okay, we'll move on to the next, which is a formula you are going to take. So magnitude of A vector plus B vector whole squared can be written as magnitude of A vector squared plus magnitude of B vector squared plus 2 into A vector dot B vector. Similarly, magnitude of A vector minus B vector whole squared can be written as magnitude of A vector squared plus magnitude of B vector squared is minus 2 into magnitude of A vector dot magnitude of B vector. Similarly, magnitude of A vector plus B vector whole squared plus magnitude of A vector minus B vector whole squared can be written as 2 times of magnitude of A vector plus magnitude of B vector. Nothing. If you add these two, you are going to get this one. How? These two will get cancelled. If minus and plus will get cancelled, 2. See here, magnitude of A vector square, magnitude of A vector square. 2 times of magnitude of A vector square. Similarly, magnitude of B vector square, magnitude of B vector square, 2 times of magnitude of B vector square, 2 taken as common factor. So all this formula you have to remember. Okay. Now we'll be moving on to solving the problem based on that formula. Here having find magnitude of A vector minus magnitude of B vector whole squared if two vectors A vector and B vector such that magnitude of A vector equal to 2 and magnitude of B vector equal to 3 and A dot B vector equal to 4. Now you are having magnitude of A vector minus B vector square is magnitude of A vector plus magnitude of B vector square minus 2 into A vector dot B vector, correct? So therefore you can substitute here, which implies that magnitude of A vector already they have given it as 2, so which we can substitute as 2 squared plus magnitude of B vector they have given it as 3, we can substitute 3 squared minus 2 into A vector dot B vector they have given it as 4, so 2 into 4. Solve this one. 2 squared is 4 plus 3 squared is 9. 2 4s are 8. So therefore 9 minus 8 is nothing but 1. 4 plus 1 is 5. So this is your final answer. You are going to get it, dears. I hope you understood this step and expanding the formula. Now we'll be moving on to the next one. If A vector is a unit vector means what? Magnitude of A vector will be equal to 1. So given, let me write down the given first. Given A vector is a unit vector. So therefore I can write it as therefore magnitude of A vector is equals to 1. Now and x vector minus A vector into x vector plus A vector equal to 8. Find magnitude of x vector. Let us expand the given. What they have given? X minus A vector, correct, into x vector plus A vector. They have given it as 8. Let us multiply x vector into x vector, correct, plus x vector into A vector. Minus into plus is minus. So x vector into A vector, again minus into plus is minus, A vector into A vector is equals to 8. Now this is a positive, this is a negative, will get cancelled. X vector dot x vector gives you magnitude of x vector square, correct. This is minus magnitude of A vector square, which is equals to 8. You know that magnitude of A vector is nothing but 1. You can substitute magnitude of x vector square minus 1 squared is equals to 8. Otherwise, magnitude of x vector square is equals to 8 plus 1. 1 squared is 1. So 8 plus 1, which is nothing but 9. So you are getting, so magnitude of x vector squared is equals to 9. Otherwise, magnitude of x is nothing but square root of 9 is 3. That's it. And this is your final answer. Be careful, they have given A vector is a unit vector. Now we'll be moving on to the next problem. What they have asked. If x vector, find magnitude of x vector if A vector is a unit vector and magnitude of x vector minus A vector dot magnitude of x vector plus A vector equal to 12. Similar type of problem I have taken here. So if A vector is given A vector is a unit vector. So, magnitude of A vector will be is equals to 1. What they have given? X vector minus A vector into x vector plus A vector is equals to 12. Let us multiply. So, magnitude of x vector into magnitude of x vector, correct? Again, plus magnitude of x vector into A vector, right? Again, minus into plus is minus, magnitude of x vector into magnitude of A vector, again minus magnitude of A vector into magnitude of A vector is equals to 12, correct? So, these two will get cancelled, more positive and negative. This is magnitude of x vector square, that is magnitude of A vector squared is equals to 12. Now, you can substitute this as 1. Magnitude of x vector squared minus 1 squared is equals to 12. Taking minus 1 to that side, magnitude of x vector squared is equals to 12 minus 1. Otherwise, you can have magnitude of x vector squared is equals to 13. Otherwise, magnitude of x vector is equals to under the root 13. So, and this is your final answer. You are going to get it as DS. Dears, I hope you understood this session, how to solve the problems on the Cauchy's squares inequality, isn't it? And also how to use the formulae based on the conditions as given. And we have also solved problems on a cosine of an angle and also projection of a vector on B and projection of B vector and on A. In the next session, we'll be moving on to some more concepts of the vector algebra and solving the problems based on those concepts. Until then, dear students, keep watching. Thank you. Have a nice day.